Hello students, myself Abhishek Arora, and today we are going to discuss the trigonometric limits, how to basically solve any trigonometric limit here. Okay, now for trigonometric limits, basically if you have seen our previous video, what I have done there is I have solved a basic sin x upon x when limit x tending 0, the answer is equivalent to 1 by using the L'Hopital rule. Okay, so all these basic formulas that I am going to show you, that is all such formulas that you have to by heart. Okay, all these formulas you need to by heart because all such formulas can be derived by using the L'Hopital rule itself. Okay, but such formulas will be again and again used in any of our formulas in our questions. Okay, so all such formulas, that these are the formulas you have to by heart. Okay, and we'll be using the same directly in the questions. Fine. So let us take a illustration by using the same kind of formula. Okay, so there's this illustration, that is your limit x approaching 0 and you have 1 minus cos 2x, 3 plus cos 2x and x tan 4x. Okay, now if you see in the formulas once, what happens is you need to solve all such questions by using your 1 minus cos 2x in this case. If you see, so solving it here, what we can do is we can directly substitute the value. But if you directly substitute the value, again what we will be getting is you will be getting a particular 0 by 0 form or different kinds of form after directly substituting the limit. Okay, so to solve such limit, what we need to exactly do is, if you see in this case, that is 1 minus cos 2x, what I have written it is as 2 sine square x. Okay, so if you see, I have taken a formula, okay, and I've converted my cos function into sine function, because if you see all the formulas, they are related to your sine and tan itself. Okay, so I'll be taking all the cos functions, the secant, cosecant, all such functions in the terms of your sine, so that the question becomes a little easier. Okay, and also if you have seen the formulas, what happens is sin x upon x is always equivalent to 1 for limit x approaching 0. Okay, but in this case, if you see, you have got sine square x, so which means if there was sin x upon x, that x and x should be the same. Okay, if sine 2x was there, that 2x, and in the denominator it should always be 2x. So in this case also, if you have sine square x, you should have a x square in the denominator. So what I'm doing here is I'm just multiplying and dividing both the numerator and the denominator by your x square. Okay, I have taken x square, so if you see sin x upon x ka whole square it becomes. Okay, and the limit we know, if we have a limit x approaching 0, sin x upon x, it is equivalent to 1. So this limit can be easily solved now. And what I have done is, as I already told you, that I am dividing my equation by x square. So the denominator, there was already one x there, and I divided my denominator by x square. So that x and x gets cancelled out and I'm only left with 1x. Okay, so if you see here, what we are having is your tan 4x. Now tan 4x divided by not x, it should always be 4x. Okay, so for that again I have to multiply and divide by 4. Okay, so I did the same and I'm left with 1 upon tan 4x upon 4x. Okay, into 4, that is when I've multiplied and divide by 4. Okay, that 4, and the basic function that we are left with is 3 plus cos x. Okay, now if you see, if we put the limit in this, limit x approaching 0, your sin x upon x becomes what? 1. Your tan 4x upon 4x becomes what? 1. And when we substituted this 0 in your cos function, then it becomes again cos 0, that is equivalent to 1. Right? So what we are left with, overall the answer becomes, when after the cancellations, what we are left with is 2. Okay, so if you see closely with the relation of all the sin x upon x, tan x upon x, or x upon tan x, all such formulas that I have already shown you, that I have told you that you have to by heart. Okay, So all these formulas are directly being applied in the same question. You just need to remember that whenever we are encountering your tan 4x, 5x, 6x or sine square x, cube x, all such formulas, okay, you just have to take the same power in the denominator itself. In like in this tan 4x, then you have to have 4x in the denominator itself. You had sine square x, you need to have x square in the denominator to solve that particular limit. Okay. Now let's move on to the next part, that is your special limits. There are a few basic special limits, that is in this case if you see, you have your limit x approaching 0, 1 plus x to the power 1 by x. Again the same thing I'm saying, what I have told you in the trigonometric part, that there is this x, and if you see in this question, in this formula, basically what we are having is 1 plus x to the power 1 by x. So whatever the x you will be having inside, you have to have the index power, the inverse of the same. Okay, so let us take an illustration to understand this concept. So if you see in this case, what we are having is 1 plus 5x square upon 1 plus 3x square to the power 1 by x square. And we can give the power to both of these functions separately. Okay, I'm doing the same thing here. I've given it to the power to the numerator, I've given the power to the denominator. Okay, now if you see, as I've told, if you have x here, then you have to have x in the inverse of the power. Okay, you have x square and you have 1 by x square, that is fine, but there is this 5 and 3. Okay, 5 in the numerator, 3 in the denominator. So what we need to do, we just have to multiply and divide the function by 5 and 3. Okay, so if I multiply my power with 5 and divide it by 5, and the denominator we multiplied by 3 and divide by 3. Now if you see the whole function in the denominator and the numerator, it is of the same type as the formula we are having. You substitute your limit, the answer to it should be E. If you see, there is this power in the numerator, that is 5, and in the denominator the power is 3. So what we are left with is, that is e to the power 5 and e to the power 3. We just cancel out both of them. What we get is e square. Okay, and we substitute the value of e, that is exactly 2.71828. Okay, so this value we substitute, and the power we take, the answer is equivalent to 7.38 in this case. Okay, so this is one of the special limit that we need to solve accordingly. The second, if we see, that is a power x minus 1 upon x limit. Again, if you see, these are the fixed limits, that is limit x approaching 0 in all such cases. The answer to this will be equivalent to log a. Okay, so again I'm taking an illustration to make you understand the concept. Okay, there is this question we are taking, a to the power 3x minus a to the power 2x minus a power x plus 1 upon x square. So what I'm doing is, I'm just taking the factors. Okay, first thing I've taken is, I've taken the factors out of it. So what we are left here with is a to the power 2x minus 1, a to the power x minus 1 upon x square. So now you see, you have a x square in the denominator. We can split it. Okay, as in the formula we require only x in the denominator, but here we are having x square. So by splitting it, I give my x to both of these functions. And if you remember the algebra, if you are having a multiplication of two functions, we can give the limit to both the functions separately. Okay, so what we are getting here is, again if you see, in the first function we are having 2x in the power, and we need to have 2x in the denominator also. Now you are understanding the concept easily, right? The same thing I am doing here, that is multiply by 2, divide by 2, and the second function is the formula itself, right? So what we are having is, the first one give you the answer, that is log a, right? And it will get multiplied by 2, and in the second function the answer will be again log a. So the answer will be 2 times log a into log a, that is 2 log a whole square. Fine, got the questions? All such questions will be done in the same manner. Okay, you just need to see that if you are having a x, you need to have the same x in the denominator itself. Okay, now let's move on to the next special limit, that is the log limit, the logarithmic limit. that is log of 1 plus x upon x, that will always give you the answer equivalent to 1. Okay, again I'm taking an illustration, very simple formulas, very simple kind of thing. If you see the function that is log of x plus a minus log of a upon x, okay, here this function, what I'm doing is, if you remember the formula for the same, log of a minus log of b, that is log of a upon b, right? Yes, correct. I'm using the same. Okay, what we are left with is, we just, after we take the division of both the functions, I have cancelled the parts, and what we are left with is 1 plus x upon a upon x. Now if you see, again I'm doing the same thing. You have a x in the numerator having x upon a type, but in the denominator it is only having x. So what you need to do is, you have to multiply and divide by a. Okay, so I've done my multiplication and division by a. The final answer that I get after substituting my limit, that is equivalent to 1 by a. So we have discussed the answer that is equivalent to 1 by a. So thank you, and if you like the video, please subscribe.